Hello, welcome back for the next session in the system drives, devices and actuators. In this session, we will discuss the vane motors, axial motors, bent axis motors, radial motors and performance of the hydraulic motors. Vane motors have a slotted motors mounted on the driven shaft, that is driven by the rotor. Vanes are closely fitted in the rotor slots, moving radially with a sealed against a cam ring. Cam ring is also called as the casing. The pressure fluid enters and leaves the motor housing through the opening in the side plates at the rams. The pressure fluid enters at the inlet port and moves the rotor counterclockwise. The rotor transports the fluid to the ramp opening at the outlet port and returns back to the tank. If the pressure were introduced at the outlet port, it would turn the motor in the clockwise. The direction of the rotor depends upon the flow of the liquid. The rotor is separately axially from the side plate surface by a fluid film. The front side plate is clamped against the cam ring by a pressure and maintained optimum clearance as the temperature and as well as the pressure changes the dimension. Vane motors provides a good operating efficiency but as high as those the piston motors. However, the vane motors generally cost less than the piston motors of the corresponding horsepower rating. The service life of the vane motors usually shorter than that of the piston motors. This slide shows how the vane motor section is. The vane motor consists of the two parts. One is the left side, the another one is the right side. The vane motor consists of the cylindrical block, which is nothing but a casing. Inside the casing, the rotor block will be there. The rotor block is mounted on the shaft. The rotor block consists of the vane slots. In the vane slots, the vanes are placed. Behind the vanes, the springs are placed. By the spring, the pressure is applied on the vanes and it is touching the cylindrical block when it is under rotary motion. As the fluid flows from the inlet, the fluid pressure is applied on the vanes and which drives the vanes to rotate in the clockwise direction. As the fluid starts exiting out, the vanes which are exited out from the vane slot will be under compression against the spring pressure. The same thing if it is reversed from the outlet to the inlet, the rotor it rotates in a reverse direction. In the next topic, we are discussing with respect to piston motors. Piston motors are classified into following types. According to the piston of the cylindrical block and the driving shaft, piston motors are classified into axial piston motors and radial piston motors. According to the basis of the displacement of the piston motors, it is classified into fixed displacement and as well as the variable displacement. In the next topic, we are discussing about the axial piston motors. In the axial piston motors, the piston reciprocates parallel to the axis of the cylindrical block. These motors are available with both fixed and as well as the variable displacement. They generate the torque by pressure acting on the end of the piston reciprocating inside the cylindrical block. The driving shaft and the cylindrical block are centered on the same axis. The pressure acting on the end of the piston generates a force against the angle swash plate. This swash plate can be tilted at different angles. This causes the cylindrical block to rotate with a torque that is proportional to the area of the piston. The torque is also a function of swash plate angle. The inline piston motors is designed either a fixed or a variable. This swash plate determines the volumetric displacement. This slide shows the block diagram of the axial piston motor. In this, the swash plate is inclined. Once if the swash plate is inclined, then the rotor speed is also little faster than that of once if it is perpendicular to the axis of the shaft. Next is the bent axis piston motor. This type of motor develops a torque due to the pressure acting on the reciprocating piston. In this motor, the cylindrical block and the driving shaft mounted on an angle to each other so that the force exerted on the driving shaft and the flange. The speed and the torque depends upon the angle of the cylindrical block and the driving shaft. The larger the angle, the greater will be the displacement and torque, and the smaller the speed. The angle varies from 7.5 degrees to 30 degrees. These type of motors are available into two types, namely a fixed displacement type and as well as a variable displacement type. In this slide shows the bent axis motor. The bent axis motor consists of the two things. One is the piston reciprocating chamber and the shaft. Once if it is at the bent at a varying angle of 7.5 degrees, then the torque it will be of very less. If it is more the angle, then the torque it will be little more. The same thing it has been discussed in this slide. The pictorial view of the bent axis motor is shown in this slide. Now the radial piston motor. The radial piston motor is a type of motor that piston reciprocates radially or perpendicular to the axis of the output shaft. The basic principle of the operation of the radial piston motors is the radial movement. The radial piston motors are low speed, high torque motors which can address a multifarious angle diverse power transfers application. Now in the next topic we are discussing with respect to the performance of the hydraulic motors. The performance of the hydraulic motors depends upon the many factors. As we know that the precision of the parts, tolerances between the mating parts are some of the basic parameters which depends, and also the internal leakage between the inlet and as well as the outlet affects the volumetric efficiency. The friction between the mating parts affects the mechanical efficiency of a hydraulic motor. The overall efficiency of the motor is better when compared to the other drives.